Alright, so 7.7 notes is all about trapezoids and kites. So our goal for today is to use properties, or I guess to learn and use of trapezoids and kites. So some previous definitions here. What is a trapezoid? What makes it a trapezoid? Not necessarily. We said two congruent sides and two parallel sides, but not necessarily. It's a very specific definition that we define. Go ahead. It does not have exactly one pair of congruent sides. Go ahead, Kyla. Yes, this is a quadrilateral. And we have to say it's a quadrilateral so that we state that it's a four-sided figure with exactly one pair of parallel sides. So what this looks like something like this. Where these sides are parallel. Okay. We actually consider this top to be a base, along with this bottom to be a base, and we call these sides legs. So that's some new stuff. I don't think we've labeled any of that yet, so that's new. But if I'm talking about a base, I'm talking about one of the parallel sides. If I'm talking about the leg, I'm talking about the sides that connect to the parallel sides. Okay. What is an isosceles trapezoid? Go ahead. What's that? Yes, this is just a trapezoid with congruent legs. And many of you guys, when you think of a trapezoid, you automatically assume isosceles trapezoid because that's how you grew up learning what a trapezoid looks like. But it's not necessarily, they're not all isosceles trapezoids. So it's a trapezoid, meaning that it has to have the exactly one pair of parallel sides. So there we go. But in this case, we also know that the legs, so the non-parallel sides, are also congruent. So this top is a base, the bottom is a base, this is a leg, and this is a leg. And this is just a refresher on the definitions, because we talked about these definitions back in the very first section. So, what is a kite? What is a kite? Go ahead. Good, a quadrilateral. Wait a minute, say that again. A quadrilateral. Yes, there we go. Quadrilateral with two pairs of congruent, adjacent sides. So the congruent sides are right next to each other. That's what it means by adjacent. So to be a kite, excuse me, the two sides next to each other are congruent. These two sides that are next to each other are congruent. Okay. And one other thing that I am going to mention here, and actually goes back to the trapezoids, are that base angles are angles that share a base. So they are at the ends of the base. So here's a base. The angles at the two ends of that base are called base angles. Okay? And then this is a base, so the angles at both ends of those are considered base angles. Okay, they're pairs. So if you want to put that in there too. They're a pair. Okay, base angles are a pair. And you kind of have to know that because in Theorem 15, it talks about base angles. That's why I brought that up. Make sure to make that note in there. All right, so it says the base angles of an isosceles trapezoid are congruent. So that means that in our diagram here, this is a base. Okay, so this base angle is congruent to this base angle. Okay, so the pair is congruent. Not only do I have those base angles, but you also have a base up here. So the base angles at the ends of these bases, or at the end of this base, these angles are also congruent to each other. Not to the other two, but those two angles are congruent to each other. So if we have an isosceles trapezoid, then we can mark those angles are congruent to each other. Okay. Also, since I know that these are parallel, if I cover this up, what is the relationship between this orange and pink angle? Not a linear pair. Linear pair, they would have to be touching. They have to be supplementary. Why? Those are same side interior angles. We have two parallel lines. Those are same side interior angles. So if we have parallel lines, then same side interior angles are supplementary. So it goes back all the way to Unit 3 when we learned about parallel lines and their properties. Okay? So we're going to add that in right here. Two angles that share a leg, because that's what this is, a leg, are same side interior angles. So that means that they are supplementary. So the orange angle and the pink angle are supplementary. They have to add to 180. So if I put this as angle 1 and this as angle 2, what it's saying is the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. The next one is going to be talking about the diagonals of an isosceles trapezoid. So let me draw in the diagonals here. I'm going to draw them on both diagrams here. I'm going to put some labels on this isosceles trapezoid. So if we have this labeled, then what we can label, or what we can state, is that segment AC is congruent to segment BD. Because this theorem says that the diagonals of an isosceles trapezoid are congruent. So the two diagonals are congruent. There was another theorem that this works for with a different shape. What was the other shape that this works for? It does work for a square, but it also works for a rectangle. So it works for a square, a rectangle, and an isosceles trapezoid where the diagonals are congruent. Remember, it doesn't work for the parallelogram because remember, you can take those corners and move these ones closer together and the other two move further apart. Remember I showed you those with the sticks? Okay. So that's all that one is. The next one says the diagonals of a kite are, and this rule says that they are perpendicular. So I'm going to draw in the diagonals of my kite here. So if you have this labeled, then you know that you can also label that this makes a right angle because those diagonals are perpendicular. What other shape does this one work for? Do you remember? It does work for a square. It also works for a rhombus. So this works for a rhombus, a square, and now a kite, where the diagonals are perpendicular. Okay. So when you're making your cheat sheet for your unit test, I would make sure to put those rules on there. When are diagonals perpendicular? When it's a square, rhombus, or kite. Okay, so those kind of things should be on there, which is why we've been, I showed you guys how to do that flow chart, and I would just keep adding little properties next to them or something. You can organize it however you want, but yes, we have learned a ton of theorems this unit. So you'll want to make sure you have some way to organize it on a cheat sheet so that way you can easily find which properties belong to which shapes. Because when you put it all in one jumbled review or one jumbled test, there's going to be a lot of properties that you have to know. Okay. So let me turn this page. Let's do a couple example problems. The first example says to find the angle measures in the figure. So it gives us one of these angle measures. And what shape do we have here? Okay, this is an isosceles trapezoid. So what do I know about isosceles trapezoids? 1 and 2 have to be congruent. Cool, I'll mark them congruent. What else do we know? The 3 and the 102 have to be congruent, so I'll mark these two. Also congruent. Okay, so then 102, what's the measure of angle 3 then? 102. All right, well, I still have to figure out what angles 1 and 2 are. How can I go about doing this? And there's a couple different ways you could do it. Give me one of them. Okay, so you're saying that the total sum is 360. So you want to subtract the, how much? 204 that we've already used. Okay, so that leaves us with so 360 minus the 204. That leaves us with the 156, and then what do we do with the 156? Divide that by the two angles that are left because it's split up evenly to say that both of these angles then have to be 78 degrees. Did you have the other way to do it? How can you do it the other way? Yes, I can look at just these two angles. What do I know about these two angles? They have to be supplementary. So if I know that, then 180 minus the 102 gets me 78 degrees, which I labeled that when I did it the first way, and I get the exact same thing. Once you have that one, it's easy to find that one because they're the same. Either of those ways are acceptable to find this. Okay? What kind of shape do we have here? Another isosceles trapezoid. Okay, so what can I label? What do I know if this is an isosceles trapezoid? The same thing I did on the other one. So these two top base angles, D and C, are going to be congruent. And I know that A and B are going to be congruent. Okay, well, cool, but I still don't know any of those angle measures. So what am I going to do here? Go ahead. Wait a minute, say that again? Okay, x plus 100 has to equal 6x. If those angle measures are congruent, I can set them equal to each other. Good. Subtract x from both sides. So I have 100 equals 5x. Divide both sides by 5. I'm going to get that x is 20. Okay, so which angle is 20 then? None of them. I have to plug it back in. So 6 times 20 is 120 here. Check it over here. Is 20 plus 100 120? Are these supposed to be the same? Yes. So measure of angle A is 120 degrees. The measure of angle B is 120 degrees. The measure of angle C, okay, so how then can I find the measure of angle C? Yeah, these two have to be supplementary, so do the 180 minus the 120, and what are we left with? 60. And then since D is the same, we know that's also 60. Okay, give me a 1 through 5. I feel like I could handle those two problems on my own. Cool. Number 2 says to find the missing angle measures. In this, what kind of shape do we have here? A kite. Overall, we have a kite, but take a look at what else you have. What is this figure here if I cut off this portion of it?
Triangle.
What kind of triangle? That is an isosceles triangle. Put it this way, maybe that will help you recognize it. Isosceles triangle? Right?
Yes.
Cool. You can use those properties as well. Or you can look at just a smaller triangle and use those properties. But kites are just made up of lots of triangles. So use what you know, and let's see what we can find. What's one thing you can label on this diagram? Raise your hand if you can tell me one of those things. Go ahead.
Number 1 is 90.
Number 1 is 90 degrees. That was one of those rules that the diagonals of kites are perpendicular. So measure of angle 1 is 90 degrees. Good. Oh wait, it told us the measure of angle 3 was 30 degrees, so let me label that in my diagram, because it's really hard to find things when things aren't labeled in your diagram. Measure of angle 5 is 40 degrees, so let me label that one. Okay, so those are my labels. Raise your hand if you can tell me something else I can label in my diagram. Go ahead.
The measure of angle 7 is 90 degrees.
Yes. If 1 is 90, then 7 also has to be 90. You could say they're vertical angles, or you could just say that the diagonals are perpendicular. So the measure of angle 7 is also 90 degrees. Give me something else that I can label here. Go ahead. Why? Yes, okay, so if 1 is 90 degrees and 3 is 30 degrees, then 1, 2, 1, 2, and 3 all have to add to 180 because it's a triangle, leaving 2 to be 60 degrees. Very good. Go ahead. 2 and 6 are base angles. So if we look at this isosceles trapezoid, this isosceles triangle, 2 and 6 are the base angles of this isosceles triangle. So I know that 2 and 6 have to be the same. So what 6 have to be? Also has to be 60. All right. Now we're down to 2. Go ahead. The measure of angle 4 has to also be 40 degrees. Why? I'm going to show you something. Isn't this just side, 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 and side, side, side triangles? So couldn't we take this and fold it in half this way? So all these angles that are up here fold onto something down here, and this actually just folds in half. So 5 would fold onto 4, and so they have to be the same. Do you kind of see that? It's a mirror image. So 4 has to be 40 degrees. What about the measure of angle 8? Has to be 30 degrees. And even if you would have taken this 60 here and figured out that that's also 90 and labeled it, we would have also found that 8 was 30 degrees that way. And you could do that with all those if you have those couple angle measures. Okay. Now, you could double check this. You could check and make sure every triangle, the angles add up to what? Make sure all triangles, the angles add up to 180. You could make sure that the quadrilateral, so this angle here in the quadrilateral is 80. This one's 60. You could figure out what this one is and that one is and make sure all 4 angles in the kite add up to what? What does a kite have to add up to a quadrilateral? 360. Okay, so there's lots of different ways you can go about checking this and make sure that we're on the right track. Okay. Let's look at this last one. Here's another kite. And it's giving us a couple different angle measures. And we're going to have to try to figure out something that we know about these angle measures in order to figure out what to do. Anything that we can label in this diagram, because it's a kite. Go ahead. We can label those right angles. All 4 of these angles here in the center all have to be right angles because the diagonals of a kite are perpendicular. So you can label all those right angles. Okay, so how does that help us? Go ahead. Okay, so you're focusing in on this little triangle here. And you see that all 3 angles have a label, right? What do all those 3 angles have to add to? 180. The 3 angles in a triangle have to add up to 180. So we have the x plus 6 plus the 2x plus the 90. That has to equal the 180. So x plus 6 plus 2x plus 90 has to equal 180. Now we just have to simplify this. So we actually on this side have 3x plus 96 equals 180. Subtract the 96 on both sides. We're going to have 3x